Hello everyone. We are continuing class 11 chemistry, chapter 4, chemical bonding and molecular shape, that is molecular structure. In the previous video, we discussed principles of VSEPR theory, its merits and demerits. Now we will proceed to know how we can predict the geometry, that is shape of molecules and ions.
But before we continue, I am Anandavali from Guidance Education channel. Please watch the video completely so that you get all points cleared. And if you think it is useful, do subscribe my channel and support me. Thank you very much. Come, let us start.
The main principle of VSEPR theory, as you know, is the repulsive force among bond pair and lone pair of valence shell electrons of the central atom of the molecule or ion, as the case may be. In order to predict the geometry, that is shape of molecules and ions, we need to know VSEP number. If we know the VSEP number of the molecule, we can predict the shape of the molecules. By shape, we mean angle between bonds. From the VSEP number, we can calculate another number called the steric number. It is nothing but the number of electron pairs around the central atom. We need these facts in order to predict the shape of the molecule. We will take two examples. An example of hexafluoride of sulfur and ammonia. They belong to two different categories. First, we will see how we can find out the VSEP number. We have to follow a few steps. First, we will take up molecules. When you are asked to predict the shape of a molecule, the first step is to find the central atom. Then count the number of valence electrons of the central atom. Then count the number of valence electrons of the atoms attached to the central atom and participating in bond formation. That is when we take up sulfur hexafluoride. Sulfur is the central atom and fluorine atoms are the atoms attached to the central atom. We have to count the valence electron of sulfur atom. That is the central atom. And also the valence electrons of fluorine, but count only those electrons which are engaged in forming the bond with the sulfur in this case. Okay, so you have two numbers here. Then we have to add up these two numbers, that is number of valence electrons of the central atom plus number of valence electrons of the atoms attached to the central atom and participating in the bond formation. That number is the VSEP number. Next is we have to find the number of electron pairs, which is called steric number. Half the number of VSEP number, steric number, or the electron pairs around the central atom. So we have the VSEP number and the steric number. VSEP number minus number of atoms attached to the central atom will give the number of lone pairs. So we have calculated lone pairs here. Then how do we get bond pair? Number of atoms attached to the central atom is equal to the number of bond pairs. We can also calculate it as EP minus LP. That is electron pairs, that is steric number minus this lone pair. That gives number of bond pairs. I hope it is very easy and very simple. You have to remember these steps, that's all. Molecular shape depends upon the number of VP and LP and also their repulsion. I am sorry, I will just strike this. Let us understand this using an example. First, we will take up a case where there are no lone pairs. We will take up the example of hexafluoride of sulfur. The first step is the central atom. Sulfur is the central atom. We have to find the valence electrons. So atomic number of sulfur is 16. Electron configuration is 286. So valence electrons of sulfur is 6. Atoms attached are fluorine. Atomic number of fluorine is 9. Electron configuration is 27. So the valence electron is 7. Total number of fluorine atoms are 6. Number of valence electrons of fluorine participating in bond formation is only 1 because fluorine requires only 1 electron to complete octet. So, 1 electron of each of the fluorine atoms participate in bond formation. So, total number of electrons of the 6 fluorine atoms is equal to 6. So, VSEP number is equal to 6 plus 6, that is equal to 12. Now, we have to find steric number. Half VSEP is equal to steric number. So, steric number is 6. Now, one important thing, steric number is 6. Total number of fluorine atoms attached is equal to 6. So, number of lone pair is equal to steric number minus number of atoms attached. So, here it becomes 6 minus 6, that is equal to 0. So, here there is no lone pair. Now we will consider another example, that is ammonia. The steric number is equal to electron pair. Lone pair is 0, electron pair is equal to 6. Okay, now we will consider one more example, ammonia. This is a case of a molecule with lone pair. We will see that the central atom is nitrogen. Atomic number of nitrogen is 7. So, electron configuration is 2, 5. So, valence electron of nitrogen is 5. Atomic number of hydrogen is 1. Total number of hydrogen atoms is 3. Valence electrons participating in bond formation is 3. So,
VSEP number
5 plus 3 is equal to 8. So, steric number, that is half of VSEP. So, you have the steric number 4. Number of atoms attached to the central atom is 3. So, number of bond pair is equal to 3 and lone pair is equal to steric number 4 minus 3 equal to 1. So, these two molecules belong to two different categories.
Now let us proceed to understand how molecular shape or geometry is determined or predicted based on number of lone pairs and number of bond pairs.
Now let us see how the electron pair number, that is steric number, is related to shape. First we will consider molecules wherein the central atom does not have lone pair. That is molecules which have only bond pairs of electrons. If there are two electron pairs, then the number of bonds is equal to 2 and the shape is linear. The angle between the bonds is equal to 180. This is the central atom. These are the two atoms attached by single bond. The molecule is linear and the angle between these two bonds is 180 degrees. So that is discussed. Next one, there are 3 electron pairs and no lone pair. Number of bonds is equal to 3. The shape is trigonal planar. How does trigonal planar look like? This is trigonal planar shape. This is the central atom. These are the 3 atoms bonded and these are the 3 bonds. This ash color and red color denotes the 2 electrons belonging to the 2 different atoms. One central atom and one the attached atom. Planar means it can rest on a plane. The angle between the bonds is 120 degrees.
Now we will pass on to the next shape.
Electron pair number is 4. There are no lone pairs and number of bonds is equal to 4. The shape is tetrahedral. This is the central atom. These are the 4 attached atoms. Here, the bond angle is 109.5 degrees. All bonds. So that is tetrahedron.
Example, methane molecule, CH4. The molecule can be represented like this. The bond shown in solid wedge, shaded one, that is directed towards us. The hollow wedge shown in white color is directed away from us. Now we will pass on to the next type.
Electron pair is equal to 5. Without lone pair, number of bonds is equal to 5. The shape is trigonal bipyramidal. This is the central atom. These are the 5 atoms equivalent to this 5 bond. There are axial and equatorial bonds. These 3 bonds are equatorial and these 2 bonds are axial. The angle between the 2 axial bonds is 180 degrees. This is one axial bond, this is one axial bond. If you consider 2 equatorial bonds, this one and this one, or this one and this one, or this one and this one. For convenience, I will take these two. The angle between these two is 120 degrees. This is one axial bond and this is one equatorial bond. The angle between any two axial and equatorial bond is 90 degrees. Okay, I hope it is clear. Now we will consider the last one, that is octahedral. Number of electron pairs is equal to 6 and there are no lone pairs. There are 6 bonds.
There are 4 equatorial bonds and 2 axial bonds.
The angle between any two bonds is equal to 90 degrees.
Now we have completed our discussion on geometry or shape of molecules with different numbers of electron pairs around the central atom and not having any lone pair. For molecules having lone pairs also along with bond pairs around the central atom, the shape of the molecule will change. We will discuss that in the next video. Otherwise, this video will be too long.
Thank you very much. We will meet in the next video. Till then, bye. Take care.